स्टूडेंट्स बात चल रही है डिजिटल टू एनालॉग कन्वर्जन की और हमने देखा था कि देयर आर 4 different techniques that are available for the digital to analog conversion. The first one was amplitude shift keying. We vary the amplitude, frequency and phase remain constant. Then we had frequency shift keying. We vary the frequency, amplitude and phase remain constant. And then we had the phase shift keying, in which we vary the phase, but amplitude and frequency remain constant. And then we had a 4th technique, which is quadrature amplitude modulation, या फिर CAM. And in this CAM, it's a combination of ASK and PSK. Students, before we go into each one of these in further detail, we need to discuss a few aspects of the digital to analog conversion that are going to be important in our discussion of these different methods of digital to analog conversion that we briefly spoke about. Students, the first aspect is that of bit rate and baud rate. Bit rate represents your data rate and baud rate represents your signal rate. Data element or signal element का concept हम लोगों ने पहले भी study किया है. They apply in their exact same constant, in their exact same expression, in their exact same concept for analog transmission as well. There is slight difference, and we are going to talk about that. And then you have got the concept of data rate in bits per second and that of baud rate in signal elements per second. Students, the second aspect that we're going to be talking about is that of a carrier signal. Carrier signal is related to the process of modulation that we have just discussed. And this process of modulation and the carrier signal is going to be important in our discussion of digital to analog conversion. इस slide पे देखिएगा कि in the case of analog transmission of digital data, our baud rate, as you can see, is less than or equal to the bit rate. So our signal rate, in essence, is less than or equal to the bit rate. Students, once again, we have discussed the concept of data elements, and in this case, as you already know from our previous discussion, your data element is, it's nothing but the smallest possible piece of information that we need to exchange, and normally that is a bit. So students, signal element का concept भी हम लोगों ने study किया था, and that concept of signal element is that it is the smallest unit of a signal. So smallest unit of signal, that is constant. Students, pretty much the same definitions apply to the analog transmission, except that there is a slight change in signal element, and we'll go through that. It's not a very big one. Now, the relationship of data rate versus signal rate, we went through that as well. So your signal rate was equal to N, which is your data rate, divided by R, ratio R. Remember, the number of data elements that are carried in one signal element. Students, in the case of analog transmission, this R is equal to log to the base 2 capital L. And students, this L that I have underlined, this L is the number of different signal elements that we have got. So to summarize, students, bit rate is the number of bits per second, baud rate is the number of signal elements per second, and important factor is that in analog transmission, the baud rate is always less than or equal to that of the bit rate. Students, another important concept is that of bandwidth required. So in the case of analog transmission, the bandwidth that is required is always proportional to the signal rate. The more the signal rate, the more the bandwidth required. The lesser the signal rate, the lesser the bandwidth required, except for the case of frequency shift keying. We'll discuss that in more detail, but for now you need to understand that frequency shift keying के case में bandwidth is not directly proportional to that of signal rate, and that is because of the difference between the carrier signals in the case of FSK that we need to add into that bandwidth. But we'll discuss that later on. Students, the third aspect that we need to familiarize ourselves with is that of carrier signal. So basically, it's the carrier signal and the concept of modulation. Students, analog transmission में the sending device produces a high frequency signal that acts as a base of the informational signal. So at the sender end, and this is important because we are going to be using it throughout our analog transmission discussion, the sender produces a high frequency signal, and this high frequency signal is the base of our information signal that we are sending. Students, this high frequency signal is called the carrier signal. So every analog transmission will need to produce this carrier signal or high frequency signal that will act as the base of our information signal. And essentially what we'll be doing is the information signal that we need to send, we will modulate that information signal over this base, over this carrier signal to send it to the sender. Students, the receiving device is tuned to the frequency of this carrier signal or the carrier signal that it expects from the sender, and then the digital information जो हमने भेजनी है, the information that we are going to be sending, that changes this carrier signal by modifying one or more of its characteristics, amplitude, frequency, and phase, and these changes will tell the receiver as to what data we are sending. Very important concept of carrier signal and modulation. This is also called as shift keying sometimes.